In today's lab, we're looking at conservation of momentum. So the law of conservation of momentum states that as long as there are no external forces acting on our system, then momentum is going to be conserved. For collision, that just means that the initial momentum equals the final momentum. So the momentum just before the collision equals the momentum just after the collision. And there are two main types of collisions. There are elastic collisions and inelastic collisions, also sometimes called totally inelastic collisions. So an elastic collision is one where both momentum and kinetic energy are completely conserved. Objects come together, they bounce off of each other, and they continue with the same total kinetic energy that they had before the collision. An inelastic collision is one where instead of bouncing off each other, they come together, they stick together, they deform, and then they continue off as one object with a single velocity. And in that case, momentum is still conserved, but a large amount of kinetic energy is lost. Now, in between those two extremes, in between the totally inelastic and the totally elastic collisions, are ones that they have properties of both. So maybe they lose some kinetic energy, but they don't lose as much as they could have if they were totally inelastic. So maybe they stick together, they bounce off each other a little bit. So those ones are more realistic collisions for what we would see in everyday life. And in this experiment, in this lab, we're testing two experiments. We're having an elastic collision and an inelastic collision. And these ones are going to be somewhere in that range. The elastic collision is going to be closer to the completely elastic side, and the inelastic collision is going to be closer to the totally inelastic side. So we're going to do those now. I'm going to go through each one separately. So if you're only doing the inelastic collision, then you can go ahead and skip ahead. We're going to go through the elastic collision first. So you can skip past that part and watch the experiment that you're going to be doing. For the elastic collision, we're going to make a large-scale DIY Newton's cradle. So Newton's cradle, that's the desk toy, where you pull back the ball, swings down, hits the other balls, and then it swings out on the other side. So we're going to do that with two pendulums that we're going to make using some racket balls and some twine. So let's go ahead and do that now. If you take one of your racket balls, and we need to attach it to the spring balance so that we can check its weight. So first of all, just make sure to zero the spring balance, and I've already done that with mine. Okay, so just hang it like that, read the value, and then I would mark this down as M1, mass 1 equals, and then whatever the mass is on the spring balance. All right, so we've recorded that, and then we need to attach it to the string. We'll record the mass of the other one later, so don't worry about that just yet. So to attach the ball to the string, just tear off a small piece of duct tape like this, and you'll really only need a half-width strip for this. So just take your half-width strip, and then you're going to tear it into smaller pieces. So you'll want pieces about this size. So I just tore this one piece into 4 smaller pieces, and I'm going to use 3 of these to attach the ball. So just take your ball and the string and use one of these pieces to tape the string to the top of the ball, just like that. So then what you want to do is just fold the string back over itself like this, so it's folded back over the tape, and then put another piece of tape over that. So you have a little bit sticking out past the tape right here, and then just pull this long section up out of the way and put another piece of tape down over that little tail. And so this kind of makes a square where the string is coming up and is suspended like that. So there's probably more than one way to do this, but I found that this way works really well, and it uses a very small amount of tape. And then so you can keep track of which ball is which, just use a Sharpie and write on the tape, or you don't have to, but just designate it somehow. So I'm just going to write M1 on here so that I know which one is mass 1, because I weighed that one already. All right, and then we need to do the same thing with the second ball. So again, just going to use the spring balance, and we'll tape the spring balance hook to the top of the ball and check its mass that way. So do that again, record the mass. This is now mass 2, M2, so I just write that down, record it on my paper. And then we're going to do the exact same thing as we did with the first one and the string. So again, just get another small piece of duct tape, tear it into some small strips, and we're going to use those to attach it to the top of the ball. So don't bother cutting the string, just get to the other end of the string and use it like that. The extra is not going to be a problem. Alright, so again, we just tape the string to the top of the ball like that, and then fold it back over itself, put another piece of tape over it like that, so we have a small tail sticking out, use another strip, and tape that tail down to the ball. And then again, I'm going to mark this one, so I'll just label it as M2. Alright, so now I've got both of these hung from the string, and we just need to attach them to the table now. So we're going to do that, again, with duct tape, and you can just tear off some strips, and half-width strips, again, work well for this. Don't need to use the full width for that. So when we set these up, we want mass 2 on the right, mass 1 on the left. That way mass 1 can come in, hit mass 2, and it swings up on the right side. So to attach this, just hang this here so that it's just above the ground, and then you'll use a piece of tape to tape it to the edge of the table. And then what we want to do is just put pieces of tape on either side of it, so this will keep it from sliding behind the tape. So just kind of wrap that there, and it kind of goes under the edge of the table and around like that. Oh, and I mentioned in previous videos, just check if your table, if the finish might get messed up by the tape, just test it in a discrete spot or use a different table for that. So I'm using a plastic table, it's not going to be a problem for mine, but just make sure that you're not going to damage your table. So I'm putting pieces of tape here on both sides, just like that. And then I am going to put another one up here on top just to make sure that the string doesn't slide down behind the tape. So that just makes sure that it stays up there, and now it swings from a single point like that. Okay, now we need to do the same thing for the second ball. So this one, we want to make sure that it hangs at the same height. So both balls need to be at the same height. They need to touch at one point, and the two strings need to be parallel to each other. So I'm just going to adjust that until I get something that works. And you'll probably have to get down next to it and look carefully so that you line it up properly. Okay, so that looks good. The strings are parallel, they're touching at a single point, and the two balls are at the same height. So now I'm just going to put the tape the same as I did before, and then we can move on. Okay, so now we just need to put the ruler underneath. So this will be for calibrating the distances on the computer. So just put that directly below the balls, and then we need to set up the camera. So again, you can use your smartphone for that with the wood block and the rubber bands. So I'll just stretch the rubber bands around the block and then connect that, put my phone in behind the rubber bands. So this time you'll want the phone in the horizontal orientation so that we can see the side-to-side motion of the balls. And if you're doing this on a carpeted floor, then you'll probably want a textbook or a book of some sort to prop your phone up on. Okay, so just line up the phone here so that it's pointing directly at the wall and at the two pendulums there, and line it up so that they're in the center of the video. So I may just shift this over a little bit. Yeah, about right there looks good. And there may not be a vertical line that you can use to orient your axes on the computer, but for me I would probably just use the floor line there or the baseboard line, and that would give me my x-axis. Just a quick reminder here, if you're using an iPhone or an iPad to film your experiment, then you need to go to the Settings app and scroll down to Camera, and under Camera go to Formats and make sure that you've selected Most Compatible. If you use the high efficiency format, then the program tracker will not be able to use your video files. It won't be able to open them. So just make sure you select Most Compatible and you should be good. And then we just need to collect data. So we're going to pull the one ball back, let it swing down, it hits the other one, and then the other one swings up on the other side. So that would be the ideal collision. We want it to occur entirely in this plane of the front of the table, so parallel to the edge here. So just stop them from swinging, and then let's go ahead and try this. So I'll start recording a video on my phone, and then I'll pull this back and let it collide, and we'll keep trying it until we get one that works. So when you do this, just kind of pull it back to a 45-degree angle or so, and then kind of look down the line here, line up the two strings, and then let it go. That one was pretty good, but we're just going to keep trying to make sure that we get several that are good. Okay, so I'm going to stop with that. That one was good, so I'm just going to move on from that. And you may have to do this several times, so be patient and just keep trying until you get one that works. And that's it for the data collection on this experiment. What I would do now is just export the one video on my phone, so trim the video shorter so that I only export the section that, that actually worked. And then I'll put that on the computer and analyze it. So when you're tracking this on the computer, use the center of the ball as your tracking point, and that will reflect the center of mass of the ball as well as the velocity of the center of mass. So that will be the correct place that you'll want to track. And if you're not going on to the second part of this video, to the second experiment, that's fine. Just make sure that you read your instructions carefully. They will have more information than what is shared in this video. So just read that, and good luck on your experiment. And now we're going to go on with the second experiment. So I'm going to clear this up, and then we'll get started on that. For the inelastic collision, we're going to use Hot Wheels cars, where one car collides into the other one, and then they stick together and move off as one unit. So first of all, we need to tape the pennies to the cars. And if you haven't already taped your pennies into bundles of 10, then you need to do that. So just make the stacks of 10, and then wrap a piece of Scotch tape around them, and make little bundles of 10 like that. So we're going to start here. Actually, we only need 4 for this. We're going to put 3 on one car and 1 on the other car. So just start off here, get a long piece of Scotch tape, and you want to tape one of them to the top of one of the cars, and make sure that when you do this that you avoid the wheels. So I'm just going to put this here so that it's right between the wheels, and then on the top of the car we'll put the other one, put the penny stack here on top, and then just tightly wrap the tape around the pennies so that it holds it tightly like that. So we get something like this, and then we're going to take 2 more stacks and put one in front of the car and one behind the car like that, and then wrap a piece of tape around that. So when you finish, you should have something like this, where you've got 3 stacks of pennies on top of this one car, and then we're going to do the same thing, just stacking one of them on top of the second car. So again, make sure that it's centered between the wheels so that it's not touching the wheels. If it does, that will add some extra friction, which will interfere with the experiment. Okay, there we go. So now we've got our two cars with the pennies taped on it, and I guess I have one extra here, so I don't need that. I'm going to set that one to the side. Okay, now I've got the pennies taped to both of these, and the last thing we need to do before we weigh them is put some duct tape on them. So these will, the duct tape will act like sticky bumpers, and that will allow the cars to stick together when they collide. So just tear off some small strips of duct tape like this, and then roll it up sticky side out. So just roll it up maybe about the diameter of a pencil, and then you can stick that to the bumper of the car. So you should get something like this, and stick it to the back side of the car. There's usually a little bit more surface area so that you can stick it like that. And then I'm going to do the same thing on this one. And when you do this, just check. Don't stick them together yet, or you'll have a hard time getting them apart. But just make sure that when they get to each other, that the tape will match up and they'll actually touch. So that looks good for now. I'm going to set them apart. Don't want them sticking together right now. So set those aside, and then we need to weigh the cars. So we're going to use the spring balance for this, and just zero it. So I've already done that with mine, but just adjust it so that the spring balance is zeroed, and then we're going to hang the cars on here. So for this, just use the axle of the car, and we've done this in a previous video already, but just hang the car like that and record the mass. So I'll do that for this one, and then we'll do the same thing for the other car. So I'll set those aside now, and we just need to set up the track. So we'll use the two segments of Hot Wheels track again, and just connect them together with the blue connector. And then you'll notice, like before, that the sides don't match up together quite right. So the edges, they kind of have a gap there, or they don't line up properly. So to fix that, just use some Scotch tape and kind of connect it so that it holds the sides together. So start it on the side where the car drives, and then just connect it to the track so that it doesn't touch the road surface. If it touches the surface where the cars drive, the wheels might run onto it and add some friction. So just do that, put it on here, and fold it over so that it kind of just holds the edge together, and then I'll do the same thing on the second side here. So again, I'll just put the tape right there, and then I'll just fold it over and tape it just like that. Okay, so just place your track then right here, and this section will be where we accelerate the car from, and then this part will be where the collision happens. So you can decide which car is mass 1 and which one is mass 2. However, I would suggest that your heavier car be the one that is stationary. If this is the one that is initially moving, then it's going to have a lot more momentum than this one, and it's going to just plow through it and just drive them off, and the initial and final velocities may be too close. So it'd be better if this one is your stationary car, so you just place that right like that, and then this one will be the one that comes in and hits this one, and then they move off to the other side. And also make sure that your collision happens after the joining point. So the connector is right here, so I want the collision then to occur a little bit away from that. So connector's right here, so I've got the collision happening over here. So then the car will come in from this side and then hit it, and then they'll move off that way. So let me just set them off the track here. I don't want them colliding just yet. Now the last thing we need to do with the track setup is add the ruler. So we'll just place this directly in front of where the collision will occur, and that will allow us to calibrate the footage on the computer. Okay, now I just need to set up my camera, so I'm going to use my smartphone for that, and the wood block and rubber bands. So I'll just stretch the rubber bands around the wood block, and then slide my phone in behind the rubber bands. Okay, so that'll go just like this, and we'll have it in the horizontal orientation so that we can see the side-to-side motion of the cars. Then I just have to place my phone right here so that it can see the collision. And just make sure that it's lined up so that your phone is parallel to the track, so these two should be parallel to each other, and then it's facing right there so that the collision happens in the center of the frame. Just a quick reminder here, if you're using an iPhone or an iPad to film your experiment, then you need to go to the Settings app and scroll down to Camera, and under Camera go to Formats and make sure that you've selected Most Compatible. If you use the high efficiency format, then the program tracker will not be able to use your video files. It won't be able to open them. So just make sure you select Most Compatible and you should be good. Alright, and then that's it. I just need to start the video recording, roll this in from the side, it collides, and then they move off together to that side. And that should be it. I'll just stop the video. And then I just need to export the video to the computer. So before I do that, I might want to shorten the video. If it's very long, like more than 30 seconds or so, then the program tracker doesn't like it very well. It's not able to handle very long videos. So you might want to shorten it and then export it to the computer. And when you track the cars, make sure to track the same point on it for every frame. So you might choose the top of the pennies or the corner of the car, something like that. So for each car, choose a point on it that you can track, and then do that for at least 5 frames before the collision until 5 frames after the collision. And you could do more than that if you want, but that would be the minimum. And that will be it. So read the instructions carefully. They will have more information than what is shared in this video, and good luck on your experiment.